Hi, this is Terry Iverson from CNC Rocks Manufacturing Camp. I want to talk a little bit about concepts of tool setting. We're using we're using a gang style machine. So this would be a gang top plate. And so the characteristics of a gang style machine is that the tools basically are ganged up one right after the other. The advantage of that is that you don't have to spend a lot of time retracting the tool, and on a turreted machine you index the turret. So you have to have clearance for that so you don't have a crash. In the time it takes to index and retract, index, and then come back down is cycle time. And cycle time in manufacturing, adding cycle time is adding cost or adding money. So on a gang style machine, this design allows you to pretty easily and quickly set up tools and pretty easily and quickly change setups. So in this particular case, there's a graduation that you may or may not be able to see on the top plate that's basically like the scale. So that allows you to locate and get a rough idea where you want to locate on the top plate. For ID operations, the reason I have this in my hand is this is a collet that fits in the spindle, okay? Remember, the spindle is where the workpiece usually is, and the collet is the work holding. It holds the workpiece. But this is a tool setting gauge that is 1 inch diameter, and you hold it in a 1 inch collet. So this would be held in the spindle in the headstock. And what you do is you bring there's something called manual pulse generator right behind me, which allows you to manually hand wheel the machine, or in this case the top slide with the carriage, and you bring it up so that this is center line of the spindle, and you bring it up so that this tool, which is floating, goes onto this diameter. So the OD goes into the ID of the tool holder. So what that allows you to do is you can then, with your Allen wrench, lock this in place. And if you look up on your screen on the position register, it can tell you in the X motion, in the X axes, where you are, what that number is as it pertains to the machine tool grid system. And then that becomes your geometric offset. So what's a geometric offset? Well, basically it tells the machine and the control where the center line of this tool is in retrospect to center line of your part or your spindle. And that's important because on these particular ID tools, you're either going to have a drill that's going to be mounted either in a bushing so that you can drill your part or center drill your part, or you might have a boring bar that you're going to want to know what this location is. Or you can use a boring bar as a turning tool on this style of machine. So this is a pretty ingenious and easy way. This is one of the more basic operations in terms of touching off, or not touching off, but setting a geometric offset. This particular manufacturer has made it very easy for you to determine where you want to put an ID tool or an ID holder. In terms of OD, square tools or OD operations, basically, once again, you slide on the top plate where you want it. You've got a scale, once again, on your top plate, and then you lock it in place. And then what you'll do is you'll want to, in many ways, you'll touch off your bar. So that will give you a geometric location of where your diameter is. And in this particular case, I think this is 5/8 diameter. And then it would also tell you if you had your face of your part or the face of your bar stock, you would call that Z0. And in programming, we call that work shift. So I'm going to go back to the work holding in the spindle location. And let's just say that your part is sticking out of your collet as such. Now obviously this is not the right diameter for the bar stock. But generally speaking, on a machine tool, the face of your spindle is going to be your 0 point. And what you're going to want to do is electronically shift and we call that a work shift, shift your Z0 out to here, and that's a one-time setting in the program. So we call that a work shift. That way this becomes Z0, and everything from that point this way is a negative number. In my programming segment, you'll see me talk about that. Anything that's from Z0 the opposite way, away from the part, is going to be a positive number. So as you program things and you look at your program, any Z dimension that's negative should be into the part, and any Z dimension that's positive should be away from the part. It also allows you to program right off of a print. So if you have a turn that's 3/4 inch long, it's negative 0.75. So it's very easy to read a program that way. So as far as the tool holders, you're going to set in a much different fashion your turning tool and your square tools. Now this particular tool is probably better utilized for probably a facing operation, where you can come across your part and do a face like so. Or you could actually do turning, but you'd have to have some geometry on your tool that gives you clearance from the actual holder and the tool itself. So these are three just very basic tools. When you get into a turreted machine, it's much different, and we'll probably have a segment about that on a slant bed machine, which would be a turreted machine. And then we'll probably do a little bit of a segment on manual machines, so that you can understand the difference of tool setting on a manual machine versus a CNC machine. One of the design features on this particular gang style machine is that this top plate can be removed and fully tooled. So what that means is there's bolts on the back side that actually adjust the gib. On the back side of the top plate is a gib that holds to a dovetail member, a dovetail plate, and it matches the dovetail. And so when you loosen these 2 or 3 bolts on the back side, this complete top plate assembly slides off. So why is that advantageous? Well, the advantage to that is that I could have a customer's job set up, or in this particular case, I have on the machine, the video, you'll see these coolant balls. So I can actually store my offsets, my geometric offsets, which we talked about a minute ago, and I can store those, and then I can slide this whole setup off and put it on the shelf, and next time I want to run it, which is what we do, I can put it back on the machine, slide it back on, tighten it down. There's a pin on the back side to stop on so that it's repeatable. Load my offsets in, load my program in, set up my work holding, change my collet or my bar stock, and I'm pretty much ready to go. And now you're going to watch your feed rate override, so you're going to want to make sure everything looks like it's where it's supposed to be the first time you run it. But I wanted to point out that one of the features of a gang style machine, this particular gang style machine, is that this top plate can be removed and put back on easily and not have to disturb the actual location of the tooling and the setup. That's a pretty big deal.